All right, dear students, as all of you know that we have I have uploaded videos regarding projectile motion, and we have discussed projectile motion in detail. We have discussed projectile motion when a projectile is shot from some height, and then we discussed projectile motion when a projectile is shot from ground. So now in this video, I'll be talking about a projectile that we shoot on an inclined plane. We have an inclined plane already, and we shoot a projectile on that plane, and how to calculate the different parameters that will be involved in that case, like how to calculate the maximum height, how to calculate the time of flight, and how to calculate the range. Now the problem is like this, that we have an inclined plane like this. Okay, so a projectile is shot from here. It is shot like this, so it will have a trajectory like this. And this is the original ground level. So we have shot a projectile with some velocity, and suppose that velocity is u. Now you see, in this case, we will have components of acceleration due to gravity. Now, if I assume that this whole angle is theta, this angle is theta naught, then obviously this angle will be theta minus theta naught. So this will be the vertical with respect to this inclined plane. Let me take some vertical component of final velocity as Vy. And this will be the vertical direction with respect to the plane ground. This is the plane ground. This is the inclined plane. We are shooting a projectile from this point. Say this point is A. This projectile is shot in this fashion. It goes like this, and it hits the inclined plane at some point. Suppose this point is N. Now we would like to resolve certain vectors in this problem. If this is theta naught, your acceleration due to gravity will be like this on this inclined plane. You can resolve this g into two components. Here it will be, if this is theta naught, this is also theta naught. So here it will be g cos theta naught. And this component will be g sine theta naught. So here we have resolved g into its components. The next thing is this u. See, this is the horizontal with respect to the plane of the ground. This is its vertical. So this distance must be, this component of velocity must be u cos theta, because this whole angle is theta. Obviously, this one will be u sine theta. Now, if I take this vector u and resolve it with respect to the inclined plane, having an angle of projection theta minus theta naught, in that case, the vertical will be in this direction. So I will have u sine theta minus theta naught. This will act as the vertical of the initial velocity, and in this direction I will have u cos theta minus theta naught. Now I think the figure is clear. The components of the vectors involved in the given problem, that's also clear. You have an inclined plane AN. You shoot a projectile from A. It goes with some trajectory, which is probably the parabolic trajectory, hits the inclined plane at N. And then you try to resolve the various vectors involved in this problem. You resolve acceleration due to gravity g into two components, g cos theta naught and g sine theta naught. And similarly, you resolve this vector u into its horizontal and vertical as u sine theta minus theta naught and u cos theta minus theta naught. Now the first very calculation that we would like to do here is we would like to calculate maximum height. Maximum height. Now, for maximum height, this will be the maximum height of the projectile. For maximum height, I have to write down equation of motion along the vertical. So if I write, okay, so we have to write down the equation of motion. We can write down v square minus u square is equal to 2as. Here it will be vy square minus uy square, that is u square sine square theta minus theta naught is equal to 2. Ay, what is ay? Ay is minus g cos theta naught. Minus g cos theta naught into h into y, I should call it in this equation for the time being. Because at maximum height, what will be vertical component of velocity? At maximum height, the vertical component of velocity will be 0. So I will write here at maximum height, Vy must be equal to 0. And what will be this y? This is a separate thing, okay? So I should rub it. So this is u cos theta. So Vy is equal to 0. At that point, y must be equal to the maximum height. So we can calculate the maximum height from this equation. So instead of Vy square, we'll get 0. So here it is minus u square sine square theta minus theta naught is equal to minus g cos theta naught h. This minus and minus will be removed. What will we get? We will get the final expression for maximum height. What will be that? H will be equal to u square sine square theta minus theta naught divided by 2g cos theta naught. This will be your expression for maximum height. When you are shooting a projectile with respect to an inclined plane, and if you want to measure the maximum height of this projectile with respect to this inclined plane, that height comes out to be u square sine square theta minus theta naught divided by 2g cos theta naught. Now, the next important parameter that we should try to evaluate is time of flight. Time of flight. All of you know what is time of flight, the total time taken by the projectile to move from this point to the point while it hits this inclined plane. That's the case here. So for that, what should I use? I will use the concept of vertical displacement. What is vertical displacement? That is y is equal to, in the present case, ut. What is u? What is vertical u? That is u sine theta minus theta naught t. All right? Then minus 1/2 of. Minus I'm writing down before because we know this g cos theta naught will be minus g cos theta naught. So for that purpose I have written here minus 1/2 of vertical component of acceleration, that is g cos theta naught. Actually it is minus g cos theta naught. So minus I have written outside. Then I would like to write t square. Now the things are clear. At this point, the displacement of the projectile with respect to this plane is 0. It will move some distance in air, will hit the plane back. That means the net displacement in this case will be 0. So I will say for time of flight, this small t must be equal to capital T, and the vertical displacement must be equal to 0. So what will I get? I will get 0 is equal to u sine theta minus theta naught. Instead of small t, I will write capital T, time of flight, minus 1/2 of g cos theta naught. Instead of this small t, I will write capital T. Okay, we can proceed like this, that minus 1/2 of g cos theta naught t square must be equal to u sine theta minus theta naught times time of flight. This square and this t will be removed. It will be minus here. So this minus and minus will be removed. What will we get? We will get the expression for time of flight in this case. So that time of flight will be, so t is here, it will be 2 will go up, so it will be 2u sine theta minus theta naught divided by g cos theta naught. This is the required expression for calculation of time period. We can calculate the time period of the projectile, which of course is independent of mass, right? So two different masses shot with the same velocity from here will reach the same point because the time of flight is independent of mass. Now after this, we would like to calculate the range. Now this, I don't know what was it, it was A, I think. Now this AN refers to the range of this projectile. It refers to the horizontal range. So how to calculate this range? I can do a small piece of geometry here. I can draw a perpendicular from here. Now this is A and suppose this is B. Now all of you know that the horizontal component u cos theta remains constant during the course of its motion. So what will be this distance? So I want to calculate the range basically. I want to write down what is this distance. This distance AB, it must be the constant velocity u cos theta times time of flight. So what will be the expression for AB? AB is not the range. AB is this distance. So this is u cos theta. Instead of time of flight, I will write this expression. That is 2u sine theta minus theta naught divided by g cos theta naught. G cos theta naught. So this will be my AB. Now if I have calculated AB, I know this angle is theta naught. I can calculate the range. What will be the range? So therefore, range R. R must be what? R is the base. This is the hypotenuse. R must be, base by hypotenuse is cos theta naught. So if I write like this, cos theta naught is equal to AB divided by AN. And AN is nothing but the range of this projectile. So what will be the range? The range of this projectile will be AB divided by cos theta naught. So we will come up with a final expression for range. What will be the range? Range will be, AB is this much. It is 2u square cos theta sine theta minus theta naught divided by g cos theta naught, g cos theta naught, and it will be square of this g cos theta naught. This will be the range of the projectile. And you must have seen how we evaluated these results. The way we have evaluated these results, you can use the same techniques to solve the problems based on the problems of projectile motion, where you shoot a projectile from some point on an inclined plane. Now the things are in the hands of the student. The student has to discover more sophisticated ways to solve the problems. The problem solving is as equivalent as that of a player. A cricket player is there, suppose, for example. There's a team of cricket players. They have a coach. And the coach shows the basic techniques. The basic techniques that can be used in the present circumstances that are there involved in that very playground. The coach does not play the actual game. He shows the path. The game is in the hands of the player who's playing on the ground. Now, the person who plays game with a beautiful skill, at the end of the day, he becomes successful. The the same kind of training is given to all the 11 players. But it is not essential that all the 11 players will have the same performance when their examination is conducted on the ground. So, anybody among these 11 can be the star. Or the things may be otherwise also. Nobody will perform. So, performance is basically the fundamental quality of the student. It is the student who has to put his pressure to get things done in a very, very beautiful way. But what is required by the student is the concept. Again and again, our responsibility is to tell them that what is the basics. What are the basic concepts involved in certain kind of problem? The problem is not only related with physics. It can be any other subject where there is a problem. Finally, the job is done by the student. It's the student who does the miracle. The teacher simply shows the way. Even the teacher cannot do the miracle. The miracle can happen only by virtue of the student. So it depends on the student how seriously he is working on some particular problem. Thank you.